is something that actually happened, and it should not be possible. A machine was given a problem so complex that the fastest supercomputer on Earth would need longer than the entire age of the universe to solve it. Not years, not centuries. Longer than everything that has ever existed has existed. And this machine solved it in a few minutes. This is a quantum computer. And in 2026, one of them crossed a line that scientists had been chasing for decades, doing something no ordinary computer could ever match. But the speed is not even the strange part, because to understand how it did this, you have to accept an idea so bizarre that some of the physicists who built it believe the answer is hiding in other universes. Let me show you how this machine actually works, and I promise it gets stranger with every step. To feel how strange the quantum machine is, you first have to see how limited a normal computer really is. Every device you own, your phone, your laptop, the most powerful supercomputer in the world, all of them think in the same primitive way. Everything is bits, and a bit can only ever be one of two things, a 0 or a 1. On or off. That is it. That is the entire alphabet of the digital world. And to solve a hard problem, a normal computer has to try possibilities one at a time. Check one path, then the next, then the next. It is astonishingly fast at this, billions of times a second. But it is still fundamentally a machine flipping switches in a line, brute forcing its way through, one answer at a time. A quantum computer refuses to play by that rule, and the way it breaks it should not be allowed. A quantum computer is built from qubits, and a qubit does something that sounds like a magic trick, except it is real and it is at the foundation of physics. A qubit does not have to be a 0 or a 1. It can be both at the same time, not switching quickly between them. Both. Genuinely, simultaneously. Physicists call this superposition. Picture a spinning coin. While it spins, it is not heads and it is not tails. It is, in a strange sense, both at once, a blur of possibility until it lands. A qubit lives in that spinning state on purpose. It holds 0 and 1 together. And if that were the whole trick, it would already be remarkable. But here is where it stops being a curiosity and starts becoming something that can outrun the universe. Watch what happens when you add qubits together. One qubit holds 2 possibilities at once, but 2 qubits together hold 4. 3 qubits hold 8. And here's the terrifying part. Each qubit you add does not add to the total, it doubles it. 10 qubits can hold over 1,000 possibilities at once. 20 qubits, over 1 million. 30 qubits, more than 1 billion. Keep going, and it gets absurd fast. At just 300 qubits, a quantum computer can represent more states simultaneously than there are atoms in the entire observable universe. Sit with that. A machine that fits on a table can hold more numbers at once than there are atoms in all of existence. And that forces a question that has haunted physics for decades. Where exactly is it keeping all of them? Think about how insane this is. A handful of qubits sitting in a lab, somehow processing more possibilities than could be written down using every atom in the cosmos. There is not enough physical stuff in our universe to store those numbers. So where's the calculation actually taking place? This is not a silly question. It is one of the deepest questions in all of science, and physicists genuinely disagree about the answer. But one of the men who helped invent the whole field, the physicist David Deutsch, gives an answer so bold it makes most people stop breathing for a second. He says the computation is real, and the numbers are real, and there is only one place they could possibly be. They are being computed across parallel universes, and our machine is quietly borrowing their power. This is the many worlds idea, and quantum computing may be the closest thing we have to evidence for it. In this view, every time a quantum event could go more than one way, reality does not choose. It splits. The universe branches into parallel copies, one for each possibility. And a quantum computer, Deutsch argues, is a machine deliberately engineered to make those parallel versions of itself work on the same problem, each one checking a different answer, and then share the result. When your quantum computer tries a trillion possibilities at once, it is not doing a trillion things in one world. It is doing one thing across a trillion worlds. If he is right, then that machine on the table is not just a computer, it is a bridge reaching into other universes and putting them to work. Now, not every physicist accepts this, but nobody has a simpler explanation for where the power comes from. But if all of this is true, there is an obvious problem. If the machine holds a billion answers at once, how do you read the right one out? And here's the cruel catch that makes quantum computers so hard to build. The moment you look, it all collapses. Measure a qubit and the spinning coin instantly falls to a single face. All those parallel possibilities vanish, and you are left holding just one, seemingly at random. Peek inside, and the magic dies in your hand. So the entire art of quantum computing is a kind of sorcery with probability. You never read the answers directly. Instead, you cleverly arrange the qubits so that all the wrong answers cancel each other out, like waves crashing into troughs, while the one right answer builds up and grows loud enough to survive the collapse. You are not searching for the answer. You are making every other answer destroy itself. For years, this was mostly theory and fragile prototypes, machines that could barely add small numbers. Critics said it might never work at a useful scale. And then, recently, the line was finally crossed. Researchers reported a quantum machine performing a genuine calculation that no classical computer, not even the largest on Earth, could realistically match. The threshold physicists call quantum advantage. The moment the impossible machine stopped being a promise and became a fact. This is not science fiction anymore, and it is not decades away. It is happening now in 2026 in real laboratories. And that changes something urgent for every single person watching this. Because a working quantum computer does not just unlock new medicines and materials, it also holds a key that could quietly unlock your entire life. Here's the part almost nobody tells you. Right now, nearly everything you do online is protected by encryption. Your bank account, your messages, your passwords, your medical records. And that encryption works because certain math problems are so hard that a normal computer would take billions of years to crack them. But those are exactly the problems a quantum computer eats for breakfast. A powerful enough quantum machine could, in principle, break the locks that guard the entire digital world. Governments know this, which is why, quietly, there is a global race happening right now to invent new codes before quantum computers can shatter the old ones. Some agencies are even harvesting encrypted data today, storing it, and simply waiting for the quantum machines to mature enough to open it later. The clock, in other words, is already ticking, and most people have no idea. But step back from the fear and look at the deepest thing this machine is telling us. For your whole life, you have assumed the world is made of solid, definite stuff. Things are here or there, on or off, real or not. The quantum computer only works because that assumption is false. At its foundation, reality does not deal in certainties. It deals in possibilities, in blurred, overlapping maybes that only snap into something solid when they are looked at. We build a machine that harnesses that fog of possibility, and it works, which means the fog is real. The solid world you think you live in is a kind of illusion, painted over a shimmering ocean of maybe, and we have just started to learn how to compute with the ocean itself. That is the true breakthrough. Not a faster machine, a window into what everything is actually made of. So the next time someone mentions quantum computers as just another gadget, another faster chip, you will know the truth is far wilder. We have built machines that may be reaching into parallel worlds, that work only because reality itself is uncertain, all the way down. That can hold more numbers than the universe has atoms, and that just crossed a threshold we can never step back over. We are right now at the very beginning of learning to compute with possibility itself, and nobody, not even the people building these machines, fully knows where it leads. The strangest part of all is that this is not a story about the distant future. It is happening quietly in laboratories today. So let me leave you with this. If reality is really made of possibility and not solid certainty, then how much of what you think is fixed about your world and your life is actually still unwritten? Tell me in the comments. And if you love ideas that quietly rewire how you see everything, subscribe to First Principles Talk. We're just getting started.